In this video we will talk about paper speed and calibration. The ECG is printed on the paper with a grid. The horizontal axis represents the time. The vertical axis represents voltage. The ECG grid typically contains thick and thin lines. Thick lines represent large squares and thin lines represent small squares. One large square contains 5 small squares. Sometimes the ECG trace is displayed on paper with dots instead of lines. Also, lines may frame only large squares and dots may represent small squares. Sometimes two adjacent large squares are marked by thicker or more prominent lines. This is often seen in ambulatory ECG monitoring. The standard ECG paper speed is 25 mm per second. This means that 25 small squares or 5 large squares represent 1 second. Sometimes an ECG paper speed of 50 mm per second is used. ECGs are rarely recorded at paper speeds of 6.25, 10, 12.5, and 100 mm per second. If the ECG is recorded at a higher paper speed than usual, the P waves, QRS complexes, and T waves will look wider than those recorded at the paper speed of 25 mm per second. Sometimes it's more difficult to find P waves at higher speeds. There is a normal ECG recorded at the paper speed of 25 mm per second. This ECG is the same as the previous one, but recorded at the paper speed of 50 mm per second. The RR intervals seem to be longer on the ECG recorded at 50 mm per second. Also, all intervals, P waves, QRS complexes, and T waves seem to be prolonged at this paper speed. In this case, 50 small squares or 10 large squares represent 1 second. The ECG recorded at the paper speed of 100 mm per second is mainly used for endocardial ECG recording. QRS complexes, P waves, and T waves seem to be extremely prolonged at the paper speed of 100 mm per second. Notches in the QRS complex, bifid P waves are easily detected at higher paper speeds. There is the impression of a slow heart rate. Conversely, all intervals, P waves, QRS complexes, and T waves seem narrower on the ECG recorded at the paper speed of 10 mm per second. There is the impression of a fast heart rate, although the heart rate is the same as in the previous ECGs. The conventional calibration is 10 mm per millivolt. In other words, 10 small squares or 2 large squares equal 1 millivolt. The calibration signal should be recorded on each ECG. If the ECG machine records an inappropriate calibration signal, the ECG may be misinterpreted. If the QRS complexes of certain leads are very high and overlap with the QRS complexes of other leads, it's difficult to calculate the height of the Q wave, R wave, and S wave. In this case, a calibration of 5 mm per MV is used. In other words, the leads are recorded at half sensitivity. Usually the QRS complex amplitude is highest in the precordial leads. If the QRS complex amplitude is high only in the precordial leads, the limb leads can be recorded at normal sensitivity and the precordial leads at half sensitivity. It's important that the amplitude of all ECG waves is reduced twice. For correct calculation, the number of squares characterizing the amplitude of the ECG wave should be multiplied by 2. Sometimes, to make some waves more obvious, the calibration of 20 mm per MV is helpful. In this case, the amplitude of all ECG waves is doubled and the number of squares characterizing the amplitude of the ECG wave should be divided by 2. This calibration can also be used when the amplitude of the QRS complexes or P waves is very small. Thank you for watching this video. Please like and subscribe.